Okay, 10.6 is solving right triangles. So this is where you learn about inverse. So now we're going to go in reverse instead of using the regular sine, cosine, and tangent. On my calculator, above the sine button, I have the inverse sine button. Above cosine, I have inverse cosine, and above tangent, I have inverse tangent. On your calculator, it may be different, so you're going to have to learn how to find those in your calculator. First one, this thing tells you we're still using SOHCAHTOA. So it tells you that if you have the sine of A was opposite over hypotenuse, like from this angle, x is your opposite, z is your hypotenuse. Then if you wanted to go backwards and you wanted to find what's this angle because you don't know the angle, you're going to use the inverse sine. And the inverse sine of those two, of that ratio, is going to give you the actual measurement of the angle in degrees. Let's go through some examples, and the examples are going to make it make more sense. So if I'm coming over here and I want to know what is this angle right here where the A is at, I'm going to go from this angle. 6 is still my opposite. It's all the way across, and 10 is my hypotenuse. So this is exactly the same as what we've been doing the last few days. Opposite and hypotenuse is still the reason why we're going to choose sine, but because we're looking for an angle, we're going to use the inverse sine. This little negative 1 on top, it's not really an exponent, it's being used in this case to show you that it's the inverse. So we're going to use the inverse sine, and then instead of setting up the equal and the fraction, we're going to put the fraction inside where we used to put the angle, because we're going in reverse. So it's going to be the opposite over the hypotenuse. That's still going to help us. The SOHCAHTOA is still going to help. Opposite's going to go on top, and then hypotenuse is going to go down to the bottom. And then this is what you put directly into your calculator. So in the calculator, you go second sine, and that gives us that inverse, 6 divided by 10, and don't forget to close the parentheses on this one. So 36.9 would be that angle right there. So the measure of angle A is 36.9 degrees. Next one, so if I'm looking from up here, I go 9 right here is my opposite, 17 is my hypotenuse. Because that's opposite and hypotenuse, I'm going to use sine. Since I'm looking for the angle, I'm going in reverse, so I use inverse sine. Sine is supposed to be opposite over hypotenuse, so 9 on top, 17 on the bottom. And then in the calculator, second sine, so that's the inverse, 9 divided by 17, put that parentheses at the end, and you get 31.96, which is 32.0. So this would be 32.0 degrees for the measure of angle A. Next one, from this angle, 16 is your opposite, 34 is your hypotenuse. Opposite and hypotenuse is the reason we use our sine. We want the angle, that's why we're doing inverse. Opposite on top, hypotenuse down to the bottom. So you go second sine. And then you go 16 divided by 34. Don't forget to close the parentheses. And it's 28.1. So it'd be the measure of angle A is 28.1 degrees. On the next set of problems, these are going to be inverse cosine, because when we do this problem from angle A, this is adjacent, and 10 is your hypotenuse. And because adjacent and hypotenuse was cosine, we're going to use inverse cosine. Cosine was supposed to be adjacent on top, that's the 8 on top, hypotenuse on the bottom, 10 on the bottom. We're still using the same basic idea on the calculator. Second cos does inverse, 8 divided by 10, and then we get 36.9. Number 5, 11 is your adjacent, 23 is your hypotenuse. Adjacent and hypotenuse is why we're going with cosine. We're looking for the angle, so it's inverse. Adjacent goes on top, hypotenuse goes down to the bottom. Put it in the calculator, and you get 61.4. Number 6, from this angle, 45 is your adjacent, because it's the leg. 53 is the hypotenuse, because it's across from the right angle. That's cosine. We want the angle, so it's inverse. And then adjacent goes on top. Hypotenuse goes down to the bottom. Put it in your calculator, and you get 31.9. So the measure of angle A is 31 point. Geez. The measure of angle A is 31.9 degrees. On the back side, there's also one for tangent. So sine, cosine, and tangent can all be done this way. So if we're looking at x, we're gonna have to ignore one of the letters. So we're gonna ignore y right now. From x, we're gonna go that's opposite and that's adjacent. And that's why we know, since this is opposite and this is adjacent, that we're gonna use tangent. So tangent. We still are looking for an angle, so it's still inverse. The opposite goes on the top. The adjacent goes down to the bottom. And then you put this in your calculator, just like all the other ones. Second tangent gives you the inverse, 10 divided by 8, and you get 51.3. So the measure of angle A is 51.3 degrees. The nice thing about having to find these is now that you know that x right here is 51.3, and you already know that's a right angle, then you can just go 180 minus 90 would be 90, and then 90 minus the angle you already know has to give you the remaining angle. So that means that y, this is x, sorry, y is going to be 38.7. And that's how you can find your second answer. So same steps on another one. If we're looking from the x over here, this is my most important angle. So I'm going to go from here. This is my opposite. 9 is my adjacent. Opposite and adjacent was tangent. And then I want the inverse tangent. Opposite goes to the top. Adjacent goes down to the bottom. And then I go second tan for inverse. 5 divided by 9. Calculator tells me 29.1, so x is 29.1. And once again, to find y, I can do 90 minus 29.1. So 90 minus 29.1, and I get 60.9. That's going to be my other angle, so y is going to be 60.9. Number 9, same process. So looking from here, 14 is my opposite, 23 is my adjacent. So I'm going to go inverse tangent. My opposite goes on top, so from x, 14 would be my opposite that goes on top. Adjacent goes down to the bottom, and then I go second tangent. 14 divided by 23. Calculator says 31.3, so x is 31.3. And then if I go 90 minus 31.3, that gives me my other acute angle. So y has to be 58.7. This part says solve the right triangle by finding each measure. So you have to find the missing side. And you can do that on here because you have two of them by doing Pythagorean theorem. And you can go 3 squared plus 4 squared equals c squared. Remember, the legs stay together. The hypotenuse goes by itself. So 3 squared is 9, 4 squared is 16, 9 and 16 is 25. If you square root it to get c by itself, there's one of your answers. And then to find angle A over here, you're looking for an angle, so you're going to do an inverse. And the ones that came with the problem, the numbers that were already there would be the 4 and the 3, so use those. From A, that's your opposite. 3 is your adjacent. Opposite and adjacent was tangent. We're looking for an angle, so it's inverse. Opposite on top, adjacent down to the bottom. Put it in your calculator. And you get 53.1. So the measure of angle A is 53.1 degrees. And then for angle B, you're just going to go 90 minus 53.1. And you get 36.9. So the measure of angle B is 36.9 degrees. So there's C, there's a measure of A, there's a measure of B. Number 11, This time you have an angle and you don't have two sides, so you cannot use Pythagorean theorem here. But what you can do, since you have this angle, is solve for x by going from that angle, this is my adjacent, and x is my opposite, and then make a choice between sine, cosine, and tangent using SOHCAHTOA. So from 40, if that's opposite and adjacent was tangent. I'm not looking for an angle, so I'm not going to use inverse. I'm going to put the angle here, and then the opposite goes on top, and the adjacent goes down to the bottom. And then remember, if the variable is on top, that's going to be multiply. So in my calculator, I'm going to put 16 times the tangent of 40. And that's going to give me x. So x is now 13.4. And then for z, I pretend I never knew what x was. And I go from here, that's adjacent. Z is my hypotenuse. And then adjacent and hypotenuse was cosine. The angle still goes here. Adjacent is going to go to the top. Hypotenuse goes down to the bottom. This time, the variable is on the bottom, so it's going to be division. But you're still going to put 16 first. And then don't forget it's division because variable is on the bottom. And then cosine 40. And that's going to be your answer for z. So z is 20.9. And then the third part is finding this angle up here because we don't know what y is yet. But all you have to do is go 90 minus the angle that you know. And that's going to tell you what y is. So the measure of angle y is 50 degrees. And I got that just from subtracting the 90 degrees that these two angles have to share minus the 40 that I already know this angle's using. Number 12 is going to be the same steps. So we look at it and go, this one has an angle and one side, so it's more like number 11. I'm not going to use Pythagorean theorem here. If I'm looking for this angle, this side down here, I'm going to go with that angle is opposite to this side, and this is the hypotenuse. And if that's opposite and hypotenuse, then I'm supposed to use sine. I do know the angle, so I put that next to the sine. My opposite goes to the top, my hypotenuse goes down to the bottom. X is on top, so I'm going to multiply it. So I'm going to write the number first, 41. And then times, because variable's on top, sine 13 goes at the end, and I get 9.2. So that means that KL, which is the X, was 9.2. When I want to find this side, I'm going to pretend X wasn't even there. I still have 41 as the hypotenuse. Y is adjacent. So adjacent and hypotenuse was supposed to be cosine. I still know what the angle is, so it goes next to the cosine. Cosine says adjacent goes on top. Hypotenuse goes down to the bottom. Variable's on top, so it's still multiplication. 41 times the cosine of 13. And you get 39.9. So this side was JK, and it was 39.9. And then the last piece of this thing is finding angle L over here. And that's just going to be 90 minus 13. And that's 77 degrees. So when it says solve right triangles, you're going to have three separate answers. Number 13, if you see that these two sides are the same, and you recognize that when two sides are the same, you're looking at a 45, 45, 90 triangle, you can save yourself a ton of work. Because if these angles are the same, then the 90 degrees that those angles share has to be split directly in half. So that means that the measure of angle B is 45 degrees. The measure of angle A is 45 degrees. And then the only thing I really have to look for is C. And there was a pattern for 45, 45, 90s, which tells us it's going to be this side times the square root of 2. So C would just be the 1 times the square root of 2, which is the square root of 2.